So everyone, welcome to the webinar, How CHOP Created a Last Mile Solution for Clinical Research Data. Today's speaker is Mike Italia, Manager of the Translational Informatics Applications Research Group with the Center for Biomedical Informatics here at the Children's Hospital of Philadelphia. Mike joined CBMI as a Senior Data Integration Analyst in 2009 after 8 years with GlaxoSmithKline. His unique informatics-based knowledge in genomics and other bench technologies related to clinical research enables him to develop systems that support CBMI's long-time personalized medicine goals. These include sample and data management, integration of genomics, clinical and imaging data, intuitive query and visualization systems of integrated data repositories, and mobile health applications. Mike has a master's in biotechnology with a bioinformatics focus from the University of Pennsylvania and a bachelor's in biochemistry and molecular biology from the Pennsylvania State University. Mike's applications research team is focused on identifying and developing informatics platforms that provide broad utility across CBMI's portfolio of projects. Additionally, the team is a driver of CBMI's active participation in the open source movement by making all code available to the community. Mike is joined by Byron Ruth, the lead developer and open source community manager of the Harvest project. And Mike, I'll hand it over to you now.
All right, great. Thanks, Mark, and thanks again to everybody for joining us today. Really excited to share with you some of the work we've been up to the past couple of years with respect to Harvest. Before I really get into the presentation, I just wanted to take a moment to introduce a few of our team members here. These are all this is not a single person effort by a long shot, and all these people have supported and contributed in some fashion, and this work that you're seeing today is really the result of all their contributions collectively. So we titled this talk The Last Mile, and I just wanted to spend a minute to kind of orient everyone on what it is we're actually talking about. And so if you think about a biomedical research workflow, you have data collection at one end, and then you have analysis at the other end. And so you might have clinical data, you might have case report forms, electronic health records, so on and so forth. You might have molecular and imaging data and all sorts of other platform data. And then you have an integration step. And you go through de-identification, data cleanup, extract, transform, and load. This step is often extremely time consuming. And then you have data reporting, exploration, and analysis. And all these things are important, but what we're really focused on today, and what I'm going to be spending the majority of the time talking about, is really the data exploration and reporting side of this. That's what Harvest is designed for. Not to say that any of these other steps aren't important; they're all vital. But this is the area of focus that we're talking about today. If we're talking about query and analysis and reporting, the obvious question always is, do we need another tool for this? There's any number of tools available that try to satisfy this need. And so the way I like to think about this is I like to think about it in this sort of layout, where you have a spectrum of generic software to custom software along one axis, and flexible data model and a fixed data model along the other axis. And in the upper corner, these are all the really generic tools. So these are the traditional business intelligence tools that have been developed. They have to satisfy a wide number of use cases, everything from financial services to healthcare reporting, so on and so forth. And so they're very, very general. These tools are, they have a flexible data model, and the software is generic, which is nice because it gives you flexibility, but you obviously have to sacrifice some usability. They often require a lot of training. Many of them are commercial products, and so that's a space that we were not necessarily interested in. Then you have I2B2 and things like it, which are a bit more healthcare focused, that have a fixed data model, but really are targeted to a specific use case. And so what we were really after with Harvest was something that could fill this space right here. So we wanted something that could be generic in the sense that we could put it on top of most of the data sources that we were interested in, but that we could tune the dial, so to speak, up and down this continuum of custom software, so that in specific usage scenarios where we need something highly customized, we could do that, and in places where a simple tool was the solution, then we could deploy it as is. And this all got started on a project called AuGenDB, which is an IDCD funded project where we're integrating both clinical data and genomic data, and the goal is really to make this a national resource. And so we started working on this project and started looking at the data and the data models, and the PI on the project was very adamant. He said we want a simple user interface. We want a Google box that we can query the database easily, and so anybody can use it. And so he had this in his head, and we we took a look at this, and really, if you want to do this kind of thing, this is the only button you can put on there as a small team in academia trying to develop something. I mean, trying to approach this from a natural language processing standpoint and everything else is just too daunting of a task. And so we took a step back and we said, well, okay, what are we actually trying to do here? What really does this request symbolize? And there's a few things that we came up with. And so really getting after here is that a user interface really needs to promote discovery of the underlying data. So people need to be able to find things easily. They need to be able to just query the data without having to think about relational databases and all of the technical issues that surround large-scale data warehouses. And we wanted to be able to deliver real-time results. And one of the things about Google that people like is you get almost instantaneous results. And so as much as possible, we wanted to enable this iteration and rapid discovery of the information. And then we wanted to present data in familiar formats. And so, lots of biomedical data is complex, and we wanted to render it in a way that was familiar and that fit the purpose that we had. And we also wanted it to be customizable. So we wanted to be able to control how the interface looked. We wanted easy to navigate reports. We wanted columns to sort properly, all of the kinds of things that you expect from a biomedical data set. And then we wanted, and probably more importantly, we wanted to make it easy to export data. So, I often say that, our ideal scenario is that someone isn't using our application for very long because they've come in and it's been so easy to find data that they're off on their own, analyzing their data quickly and outside of our application. So when you think about this, though, really those don't necessarily have to be specific to AuGenDB, and we realized pretty rapidly that there's a lot of applications that have similar requirements, and we encounter this a lot in our work in that we have specific projects where they are maybe 80% similar to other projects we've done, but require a small amount of customization. And so we thought, with this, could we build a set of reusable components on AuGenDB that we could then apply to other projects, and that's really where Harvest came from.